Okay. Everybody look up here. I'm going to draw, we're going to just kind of, I don't know how well you can probably simulate this, so I'm going to draw it. Or, I'm drawing an angle here, correct? How do we measure this angle? What do we measure it in? First of all, we measure it in what? You really, guys, really don't know what you measure an angle in? Degrees. Degrees, thank you. Okay, how do you measure degrees? Along A? What does your protractor look like? Half of a circle, doesn't it? Now, if I was to use this as a protractor to measure this angle, I put it right there, I line it up with the, what is the measure of this angle? Anybody? Say it's really close to 40 degrees. That's not quite 40, so it's what, 38 degrees? Okay. Now, what did I measure that on? On a what? On a what? Circle, right? Now, I want you to watch what happens. I put that there. See, that's 38 degrees of the circle. There's the rest of the circle, isn't it? Everyone agree? So from here to here is 38 degrees because this angle is what? Does that make sense to everybody? Everybody okay with that? What about the measure from here all the way to here? What do you think that is? Anybody have a guess? Excuse me? Nope. From here all the way back around to here. Okay. When you do a 360, how do you go? All the way around back to where you started? Why do you think they call it a 360? 360 degrees. So when you start somewhere and you go all the way around and end up where you started, it's at what? 360 degrees. But what I'm saying is from here to here. So what am I going to do? 360 minus what? And what do you get when you get that? Huh? 322. What we've actually done is measured the arcs here. What is this right here? This is the what? Center of the what? Circle? Would everyone agree with that? So that's the center of the circle. We'll call it A. We'll call this B, call this C, and then up here I'm going to put a D. It turns out that angle BAC is called a central angle. Why do you think it's called a central angle? Because it's in the center. You guys can write this down. I'll freeze it and you can write it down in just a second. Okay? That's called a central angle. What do you think that is? What do you think I'm saying when I say that right there? Huh? Arc? Yep. That is arc BC. Now, here's my question to you. Where do you think arc BC is telling you it is? It's saying start at what? B and go to C. Most of the time, where would you guys go? What do you think the measure of arc BC is? What would you guess? Huh? 38 degrees. If we measure an angle on an arc that goes all the way around 360 degrees, wouldn't you think we'd measure an arc on this exact same way? See, the arc measure is the same as the measure of the central angle that contains it. Now, here's the deal, though. Can anybody tell me another arc that goes from B to C? We're probably all, when we first look at this, we're probably all going to look at the short way, aren't we? Right? But isn't there a what? The long way around? Everyone agree with that? So what in the world do you do here? Can anybody guess how you name this arc? Well, we name this arc B to D to C. And we would, of course, say that arc BDC. That's how that reads. What do you think the measure of arc BDC is? Anybody? Louder. 322 degrees. This right here is called a minor arc. Why do you think it's the minor arc? It's the shorter distance, right? What do you think this one's called if you're guessing a name? Huh? This is the major arc. Because think about it. Any angle I draw on there, and I tell you to go from point B to point C, even if it had been here or here, there's always going to be two ways to get there. The short way and the what? The short way is the minor arc, which we only use how many letters to name? 2. The long way is the major arc, which we need to use what? 3. That way, you always know where you're talking about. It's like giving somebody directions. I want you to go short way from B to C. If I want you to go to long way, I'm going to tell you to go to B, then go to what? Somewhere else, and then go to C. Does that make sense on the logic of why they name it like that? Because really, if I say go from B to C, is there two different ways for you to do that? So there would be confusion on which one I was talking about. A lot of this, as I've said before, in geometry, the biggest thing to get over is learning the language. I mean, doesn't it make sense to, okay, if I'm going to talk about the long way around, put another point in to tell me you're to go the long way, right? If you're going if I just say from here to here, I always want you to go the what? If I just use 2 letters, I always want you to go which way? The short way or the long way? Short way. If I want you to go the long way, I'll use how many letters? 3. Okay? The only time you get in trouble with that rule is when you have a semicircle, right? Which is half of a circle. Then you're probably, for that one, you're always going to use 3 both ways. So you know which direction you're going. So I'm basically telling you where to mark with your pen or pencil. B to C, or then B to what? D to C. Everyone understand that a central angle is the angle that goes through the what? Center. These look like 2 arms holding the arc. If the major arc is 38 degrees, then if the angle is 38 degrees, then the arc it contains is what? 38 degrees. But that's only the case when it goes through the what? When the angle goes through the center, and it's a central angle. Okay? Write that down, and we're going to go straight to doing some workbook problems, because to tell you the truth, the best way to figure this out is just to kind of do it on the board. You guys in the center row scoot over a little so I can, because I'm going to shine a picture up there so I can, that's probably good. I'm going to shine a picture of page 125 on there so I can highlight and then erase. And I need to record it. Does everybody understand the concept of what central angles and all this? Because it's something that you may have heard before, but if you have, it's it's not something you've gotten into, I think, a whole lot in math, has it? Have any of you guys ever heard of central angles? Or I've always thought that this is something that, as easy as it is still new, which adds a little bit of difficulty to it. In other words, just learning the angle, knowing what in the world they're talking about. Learning the language. Don't forget, notes are half your semester test. How we doing? Has everybody about got it written down? We getting close? I hope some of your parents who are in first hour watch this video and see how asleep you are, make you go to bed earlier. Good night. Devin, will you turn the light switch that turns those first three off? I always forget which one it is. Other one. There you go. Okay, we ready? Okay. Okay, let's look at these. And like I said, this is a pretty easy section. First it says measure arc EA. First of all, AC and EB are diameters, so they're telling you that that's the center, that those go through the center. What do you know? If something's diameter, how big, what do you think the arc, what do you think the arc, EB arc is, or EDB arc? What's that got to be? How many degrees? 180. It's half a circle, right? Okay, circle R. Identify each arc as major arc, minor arc, or semicircle. Then find its measure. EA, is that a minor arc, or a major arc? Huh? Minor. First we'll go through and we'll talk about what type they are. CB. BC. DEB. D to E to what? That's a major. Is it the long way around, the short way around? Is there a faster way to get from D to B than going through E? Is there? Yes, there's this way, right? If it's over 180, it's going to be a major. AB. and CDA. So much. CDA, see how that's diameter? Sorry. Okay, now let's find their measure. First of all, we're talking about E to A. So we're talking about here to there. So of course we're talking about the measure of that central angle. What do you think is going to be a big help to me in this section? What do we need to remember back? I bet there's going to be a couple of really important things. Vertical angles, absolutely. Anybody else? Linear what? Pairs. If it's a straight line, what do I know that angle is? 180 degrees, right? No matter how I draw it. What's that? Everyone agree? That is something you're going to look for here, because they're not going to tell you everything. Okay. Obviously, those add to 180, but that doesn't help me find that one, does it? But, are these two lines intersecting? So what type of angles are they? What does that make this angle? So what does that make this arc? Arc's the same. Make sense? So what's the measure of this arc? Any questions on that? Your silence is either you don't understand or you're not awake. Which is it?
We're not awake.
Yeah.
And we don't understand.
Well, which is? It's one of the. You're not awake and you don't understand? Okay, what do you not get about it?
No, I said we got it. Same.
Measure of arc C to B. Can someone please tell me, Crop, what's the measure of arc C to B? I can't hear you. You guys agree with him? I do too. It's first for everything. Arc D to C. That's this arc right here. What is the measure of that arc? Let's see. Taylor? 100 degrees. Do you guys agree with it? Disagree with it? I agree with it. Because the central angle was what? 100 degrees. Okay? What about arc DEB? D to E to B, all the way around to there. But here to here, what do you think, Evan? That's 30. And then what's here to here got to be? So together it would be what? Does everyone see that? See how easy this is? It's pretty easy, isn't it? Do I need to do any more? Are we good? Semicircle's always going to be what? 180 degrees? Now, we're going to pull this same picture up, get your notes back out. measured an arc, didn't we? Now we're going to talk about how to find the length of an arc. Now, here's where you can, it'll help you. Measure is always in degrees, right? Length is always how far you go somewhere, right? How far you would walk. If I said the length from E to D, I'm not asking for degrees. I'm asking how far did you go if you walk from E to D along the outside of this circle. Okay? Does anybody know, how do we find that measure? What did we learn in section 10.1? If I started at E, started walking right here, and I walked all the way around and got back to there, how do I find that distance? What is that called? It's called circumference. Circumference is equal to what? 2 pi what? R. Or circumference is equal to what? Pi d. It really doesn't make a difference. It's the same thing, correct? Now, what if I walked just half that distance? How can I find that? I could basically find the circumference, then cut it in half, right? Divide by 2. Basically, 50% of it, correct? Well, if you think about it, all the way around is how many degrees? 360. Well, wouldn't it work out? How many degrees did I walk if I only went halfway around? No, write this down. 180. What does that reduce to? Right? So basically, what would you do? You would take your circumference and you would multiply it by 1/2, wouldn't you? Right? What we've got, and I'm just trying to explain to you what the formula for arc length is and how they get it. Call it arc xy is always equal to the measure of arc xy divided by all the way around. How many degrees are in a circle? 360 times pi d, which what does that represent? What? Which is the circumference, correct? That's how you find arc length. So write that down. I'm saying if you have any arc from x to y, you take the measure of that arc, you divide by 360, then multiply by the circumference. So you basically find out what percentage of that whole thing around it is. 50%, 20%, 25.2%. You change it and multiply it times what? Whatever your circumference is. So if you went a quarter of the way, if the whole circumference was 10, and you went 20%, that would be what? You walk 2, right? It's 20% of 10, isn't it? So as an example, let's say that this radius, what does it look like? It's like about 1 foot. Say the radius was a foot there. I want you to find the length of arc DAB. How am I gonna do that? Hmm? I'm gonna put something over 360, then I'm gonna multiply it times pi, and then I'm gonna multiply it times what? The diameter, correct? What is the diameter? Everybody stop, just watch. What is the diameter here? The radius from here to here is 1, so the diameter is what? 2. What is my arc length? That's what goes right here. 210? If you guys are curious how you should put this in your calculator, that's over 1, isn't it? You're basically multiply everything on top, everything on bottom. You've got 210 times what? Pi times what? 2, all of that divided by what? So just do that, times that, then press equals, and then press what? Divided by 360. Now, if they ask for it in terms of pi, that'd be different. And they may do that. In terms of pi, this would be 420 pi over 360. 6 will go into that 7, 6 will go into that 6. 7 pi over 6, that would be in terms of feet. That's in terms of pi. Round to the nearest 100, how many feet would it be? What you get, Rob? 2 times pi times 2, or 2 times pi times 210 equals and divided by 360. What do you get as a decimal? Round to the nearest 100.
3.7. No, 3.67.
Is that what you guys got?
Yes.
So you're saying if you walk from here to here, you walk 3.67 feet. In terms of pi, it's 7 pi over 6 feet. Any questions there? So this is what you do to find the what? Length. So don't get length and measure mixed up. Length is what? Basically the piece of the circumference the thing is, right? So if it was 60 degrees, you would put what there? 60 over 360 times the circumference. So you're going to be finding the circumference a lot, you're just going to be multiplying it times a fraction, aren't you? Over 360. So this is how you find the length. The other is how you find the what? Measure. The measure's always in what? Tell me. Degrees. Length is always going to be in length units, feet, meters, centimeters, things like that. Okay? On your worksheets, I did goof when I was making these. I had chapter 8 in my mind. So I wrote 8.2 on the top of these. All of you, as you get it right now, I would like you cross out the 8.2 and write 10.2, please. Can you do that for me? Because we're going to try to get chapter 10 done before we get back from break. Before we leave for break, I am shortening the assignments this week so we can get the 4th section in of chapter 10 by basically making them a worksheet. So I know you can get these done a little bit faster because you don't have to write the problems here or anything. However, what is at the top of every single page on this worksheet? Do you think I want to see that formula every time? Yes. Do I care if after this point or something you do the rest of the calculator? Of course not. But I want to see as much work as I can. Now, if you'll notice, the first one say, name your central angle. want to name the central angle of the arc given. What's the central angle for DFE? That's D to F to E. Well, that's angle EQD, isn't it? The major arc for angle CQE. CQE. What would be the major arc here? For this angle right here. And I suggest you draw out the angle each time. What's the major arc? This one would be the major arc, wouldn't it? How would I name that? I put the arc sign, and what would I say? C what? On number 2? This is your angle. Forgot to change the page. C to what? What's the major arc? CFE. You're done. Do little things like this to show me you understand. Okay? You guys think you can do that? See we have problems like that? Now hard, let's try to look at 21. How hard is this? And if they're going to give you radius each time, what should you use as your formula for circumference? 2 pi what? R. So in number 21, what would the length there be? What would be the length of this arc? Anybody? 2 times pi, what's the radius? Huh? 5. What do I have to multiply this by? Somebody? 315 over 360. So basically on the top you have 315 times 2 times pi times 5. All of that divided by what? It says round your answer to the nearest tenth. What do you get? Somebody? So 315 times 2 times pi times 5 equals, divided by 360. He was right. 27 point what? And what are the units? Meters. Circle your answer. You guys think you can do that? Let's get to work.